In this tutorial, we'll be discussing about the general formula and general nomenclature and what are the prefixes and suffixes of different groups of hydrocarbons and functional groups. So let us consider first the alkane. Alkane, they are also known as paraffins. Paraffins. So they are affinity or paraffin. So they are basically inert materials and almost a higher membered alkanes will be like paraffin wax. So wax type of material can be obtained from the higher membered, that is very long chain alkane. But lower membered like methane, ethane, propane, these are all gases. So from the gas, with the increase of molecular mass or that is the hydrocarbon chain, the physical states vary from gas, liquid, and then solid. Now let us consider the alkane first. Alkane, it has the general formula CnH2n plus 2 and they have the suffix ane, A-N-E, A. So we can cite various examples. The first member of the alkane is methane. Second member ethane. So methane is it has the formula CH4. So, and N represents the number of carbon atom. N represents the number of carbon atom. So when N is equal to 1, you can apply this formula, general formula CnH2n plus 2, so that you are able to get CH4. When N is equal to 2, you are able to get C2H6. So likewise, it is ethane. We can proceed. Propane, butane, pentane, hexane, heptane, octane, nonane, decane with the increase of number of carbon atoms up to 10. So it exceeds further also, but at least we should know up to 10 number of carbon atoms. Okay. Then olefin, it has the that is double bond and their original name is alkene. So alkenes can also be called olefins. That is, most of the oils you can find such type of compounds. So Oli is the prefix for oil. So oil base. So basically it may be present in oils. So olefin. So CnH2n, C2H4, ethene, methane. It can, methane is not feasible because we need minimum two carbon atoms to establish CC double bond. Here you will be having in alkane, you will have only CC single bond and they are satisfied with the single bond. That is why they are called saturated hydrocarbon. Okay. And these are all unsaturated. Olefin, alkene, unsaturated and similarly alkynes are also unsaturated. Okay, so alkenes and alkynes are unsaturated because they are having C double bond and C triple bond respectively. Now let us consider alkene. It has the general formula CnH2n. So the starting compound is C2H4. So ethene, propene, butene, pentene, hexene, likewise it goes. Now what is the molecular formula of hexene? Hex means 6, so C6H12. Okay, so likewise you can go. And similarly, alkynes can also be called acetylenes. Okay, so C2H2 initially by trivial name it was called acetylene, but later IUPAC we have according to IUPAC name we have the standard name ethyne. So alkyne, YNE is the suffix. So C2H2. So how we got this formula? CnH2n minus 2. So put 2 twos are 4 minus 2, 2. So C2H2. Can you get me the molecular formula of propine? Prop means 3. So C3, 3 twos are 6 minus 2, 4. So C3H4 is the propine. Okay, so likewise you can build up various number of molecules. Then alcohols, their IUPAC name is general name is alkanol. Okay, so CnH2n plus 1. This is alkyl group where OH is attached here. So it can be easily written as RCH2OH as the general group, general formula. So where R can represent hydrogen, from hydrogen you can take. So CH plus CH2, CH3. So the first compound is methanol. So this is methanol. Okay, methanol. Methanol. Second is ethanol. C2H5OH is ethanol. C3H5OH is C3H7OH is propanol. C4H9OH is butanol. So likewise it goes. Methanol, ethanol, propanol, butanol, pentanol, hexanol, heptanol, octanol, nonol, decanol, like that. Then aldehyde. So the first compound is HCHO. The first compound is HCHO. So CHO is the aldehyde group and CnH2n plus 1 CHO. So where assuming that n is equal to 0, so it is what? H only. Is it not so? HCHO, that is formaldehyde. So formaldehyde, that is also called methanal by IUPAC name. So the first compound is methanal, AL, methanal. And the next compound is ethanol, propanol, butanol, pentanol, etc. Okay. Then now let us come to carboxylic acid. I hope that is we already discussed about the function groups. So function groups are, in the case of alcohol, it is OH. What is the function group of aldehyde? CHO is the function group of aldehyde. And which is the alkyl group? Or CnH2n plus 1. It is represented as R. Okay, right. Then carboxylic acid. So here carboxylic acid can be called alkanoic acid. Okay, alkanoic acid. So they are represented by RCOOH. You know already R is nothing but alkyl group, CnH2n plus 1. And this is a function group, alkanoic acid. So what is the first compound? That is HCOOH. That is called formic acid. And by IUPAC it's called methanoic acid. Please note down, methanoic acid. And what is the next compound? Ethanoic acid. What is molecular formula? CH3 COOH. Is it not? CH3 COOH. And the general formula CnH2n plus 1. So R methyl for alkyl group, the general formula is CnH2n plus 1. You can add with COOH so that it becomes alkanoic acid. Okay. And here, so you have alkyl group. So as we already discussed, I have isolated this alkyl. It's not a compound, it's a group. Okay. So with which, it is going to attach with a different functional group, and thereby you are able to get different compounds. So CnH2n plus 1, where R represents methyl, ethyl, propyl, and even it can start from, you can call it, there is R starting from H. So H and CH3, then C2H5 and C3H7. So likewise it goes. Okay, right. And carboxylate, the anions of carboxylic acid are called carboxylate, and it can be called alkanovate. Okay, suppose if it is formic acid, formate, methanoic acid, methanovate, ethanoic acid, ethanovate, or you will follow. So this is ethanoic acid. You call it here ethanovate. How? Because let us consider CH3COOH. It's called ethanoic acid, from which H plus is removed as proton. Now you have CH3COO minus, and this is called alkanovate, that is ethanovate. Okay, as carboxylate anion. What about this? This is ethanoic acid. So likewise, we should be able to write down the alkanovate stuff. General name is alkanovate. So this is acid. The respective ion is ethanovate. Okay. So alkanoic acid, alkanovate. So shall we represent this by a general formula? So it can be represented as RCOOH. What is this? Carboxylic acid. And how to call it? Alkanoic acid. Note down, alkanoic acid. Okay. So this alkanoic acid can be separated as, you can remove the proton H plus, then you are able to get RCO minus. What is this? This is called alkanovate anion. Okay, alkanovate anion. So that if it is a formic acid, you can write a formate. Formic acid is the common name. And what is the IUPAC name? Methanoic acid. Let me write formic acid. HCOOH. Okay, so this is called formic acid. And this forms what? Formate HCOO minus plus H plus. So this is known as formate. So formate is the common name, but IUPAC name is formic acid, methanoic acid. Okay. So the respective ion is methanovate. Okay. So again, call it methanovate. So once this methanovate is, when is formed, then it can form as a salt as well as esters. Let us talk about ester here and the salt here. So let me have HCOO minus, add Na plus. What are you able to get? HCOO-Na. What is this? Sodium formate. Are you able to understand this? Sodium formate. This is a common name. And what is the IUPAC name? We know already the IUPAC name of HCOO minus. That is methanovate. So it can be called sodium methanovate. Are you able to understand? Sodium methanovate. Can you write down potassium ethanoate? Ethanoate is C2CH3COO, and so potassium means that's all. So CH3COO. Okay. So how do you call it? Potassium ethanoate. Are you able to follow? And what about the common name? Potassium acetate. That's all. Okay. Right. And as esters, esters are formed by combining alcohol. How to represent the alcohol? You can represent the alcohol like this, ROH plus and COOH. Acid plus alcohol gives ester. Let us call acid or COOH plus ROH. Okay, so they form and this H and OH. So water is removed so that you are able to get RCOO. In order to distinguish this R from this carboxylic acid, or you can put trine also. So this is from alcohol and this is from acid. Okay. So let us. This is known as ester. Okay. This is known as ester. So ester general formula is RCOO. So where we can have this, for instance, let me take CH3COOH acetic acid or ethanoic acid. Now CH3OH. So this is methanol. So you are able to get CH3COO and CH3. That's all. Plus water. So this is methyl ethanoate. Are you able to understand this? Methyl ethanoate. So this is the ester. So you should be able to write down the structure as well as the IUPAC name of this ester. You understand what is this? And what is the common name for this? Methyl acetate. So methyl acetate. That is the common name. Understand? Right. So let us go back here. So we are able to get what? That is alkanovate. Alkanovate is the carboxylate. Alkanovate is the general nomenclature, general name for this. That is carboxylate anions. Carboxylate anions. Okay. Then what about ketone? Ketone, they have CO bond here. CO. So dimethyl ketone, and it can also be called 1, 2, 3 pro. So propanone. So this can be called propanone. So it means two alkyl groups, they are surrounded by, the CO group is flanked by alkyl group, two different alkyl group or same alkyl group. Likewise, you are able to get ketone. So the general formula CnH2n plus 1 CO, CnH2n plus 1, or it can be called RCO or dash. Okay. Now let me talk about this ketone. So ketones and aldehydes together, they can be called carbonyl compounds. Okay. So generally they are identified by, okay, so this is the carbonyl group where you can have various substitution. For instance, as I already mentioned, this is generally carbonyl group. Okay, now let me build up various types of groups here. C double bond O. So when I put R here and H here, this becomes aldehyde, or you will understand, or CHO. Now when I put C double bond O, R on both sides, or you will understand, then it becomes what? RCOR. So this is called ketone. What about this? This is aldehyde. Okay, and how it should be called? Alkenyl, Al. And what about this? Alkanone. You have to include the number of, carbon atom present in the C also. Okay, so as I already mentioned, suppose if it is a CH3, CH2, CHO, how do you call it? CH3, CH2, CHO. So how to call it? 1, 2, 3. So propanol. Or you will follow. And here CH3, CH2, CO, CH3. So what do you call it? 1, 2, 3, 4. So in second position CO is here. So you can call it 2 and butanol. Or you will follow. So 2 butanol or 2 butan 2O. Okay. Right? And what do you call this one? CH3, CO, CH3. The common name is acetone, very popular compound. Acetone is a very good solvent in industries. And this can be called propanol. Is it not? Why? 1, 2, 3. Three carbon atoms are there. So propanol. Okay. So these are all aldehydes and ketones, and we can derive the function, carboxylic acids also based on this. See that C double bond O, I can put R here. When I put OH here, then it becomes what? RCOOH. So what is this carboxylic acid? Are you able to understand? About which we already discussed. So carboxylic acid. So carboxylic acid, similarly, you can have R C double bond O, and here you can put that is in place of OH you can introduce NH2. So then it is called amide, and IUPAC nomenclature is alkanamide. Alkanamide. Okay, alkanamide, or generally amide, acid amide you can call it. So suppose if it is a CH3CONH2, it is called acetamide. CH3CONH2. What do you know? What do you call it? Acetamide. So this is the acetamide is a normal, trivial name. IUPAC is 1, 2, that is ethanamide. So it should be called ethanamide. You understand? So we can build up ester also based on this. You have already this RCOOH, So what we can do, or C double bond O, you can put O and R. Prime. So this is nothing but ester, is it not? So about which we already discussed. Okay. And you can derive the carboxylate anion also. C double bond O. So on one side, so here you can put K or any cation. So it becomes what? Carboxylate, that is salt. Okay, so carboxylate ion, carboxylate compounds. Okay, and you can have acid chlorides also. You have or C double bond O. You will put OH. Okay, so remove this OH and put Cl. Then you will get what? RCOCl. It's called acid chloride or acyl chloride. Okay, so likewise acyl chloride or acetyl chloride. Okay, so likewise, in fact, carbonyl groups are said to be the queen of organic chemistry because millions of organic compounds and derivatives can be made from this carbonyl group, and that's why it's called queen of organic chemistry. Okay. Then ether here, the oxygen is flanked by two, it is bridging two different alkyl group or same alkyl group. They are called oxy compound, that is oxymethane, methoxymethane, ROR. So let us talk about this ether. So ether is nothing but ROR. It is represented as ROR, that is CH3OCH3. So methoxymethane. So it should be called methoxymethane. And what is the general compound name? That is ethers. They are called ethers. Dimethyl ether you can call it. Okay. And suppose CH3, CH2, CH2O, CH3. So what about this? This is methoxy 1, 2, 3. That is propane. So it should be called methoxy propane. Okay. Right. And you cannot call it propoxymethane because you should give weightage to what? The less number of carbon atom for prefix. And according to IUPAC nomenclature, the parental hydrocarbon should have long chain, that is high membered hydrocarbon. So the skeleton should have lengthy carbon chain. So in that case, methyl versus propyl, which is having lengthy carbon atoms, propyl has more number of carbon atoms. So that is the basic what? The carbon skeleton. So it should be the parental, that is carbon chain, and that is why it's called propane. So methoxy is the substituted one. So methoxy propane. Okay.